sometimes you might be left with systems in which you have more than one variable. Now, these systems do become solvable if you have enough equations that reflect the number of variables that you have. So what you'll see here on the screen is we have two equations that utilize two variables, x and y. This is a solvable system. You can actually figure out exactly what x and y are. Now, for this section, I'm going to be going through two different methods of how you can do this. The first one we're going to talk about is the one that is typically more utilized, which is algebraic substitution. And the second method we're going to talk about is faster if you know how to use it. Now, when you're left with these two equations and two unknowns, the question becomes, how do you go about solving it? And the answer is to do things one at a time. What you're typically going to want to do here is you're going to want to solve one of them for one of the variables, and then use that variable in the second relationship to get a solvable equation that only has one variable in it. Now, to do so, it doesn't matter which one you start with, so we're going to start with this top one here. It also doesn't matter which variable we're going to solve for. So here, we're going to solve for y. All right, so we're just going to take this top one here. We're just going to get y by itself. Now, to do so, it follows the same procedure that we've been dealing with before. If we want to get y by itself, we got to get rid of everything else. So one thing that you can do here is just like before, we're going to get rid of everything that's not y, and we're going to do so by eliminating them with opposite operations. So what you'll notice here is on the left-hand side we have 5 and x all together. If you are solving for y, you can actually treat the variable term 5x as if it were just a single item that you want to get rid of. So what you can do here is you can subtract 5x from both sides. What this does is on the left-hand side, it cancels each other out, and on the right-hand side, you'll have 10 minus 5x. Unlike before, there's not much you can do with it, so you would just leave this as 4y is equal to 10 minus 5x. Now, we still want to get y by itself, so the second thing that we can do here is we can divide both sides by 4. Again, and make sure you divide the entire side by 4. On the left-hand side, we're just going to be left with y, which is what we want. And on the right-hand side here, we're going to have 10 minus 5x over 4. Now, some people might want to leave it like this. However, I'm not a huge fan of it. What you can actually do here is if you have 10 minus 5x both on the numerator all divided by 4, you can actually just divide both these numbers that are on the numerator by their common denominator. So you can actually simplify this down. Take 10 divided by 4, which is 2.5, and then you can do 5 divided by 4, which is 1.25x. So you can do some tricks here with manipulating coefficients if you want to simplify your system down. Now, once we have this, we're going to utilize this in our second equation here to get something that is solvable. And the idea is we're going to isolate and substitute for y. So what we're going to do here is we're going to put a pair of brackets around y. And basically, we're going to take what y is equivalent to and basically jam it into those brackets. This is where the substitution comes in. We know that y and 2.5 minus 1.25x are the same. So we can simply replace y in this second equation with 2.5 minus 1.25x. So if we do this, what we will have here is the 6x. We haven't done anything to it, so it's going to stay there. The 8, again, we haven't done anything. It's going to stay there. And for y, we're going to replace it by 2.5 minus 1.25x is equal to 8. What you'll notice here is our equation only has x's in it present now. Now, to solve this, it's going to use most of the things that we talked about before. 6x, again, stays the same. We can get or expand out this bracket by distributing. In other words, we can take this 8 here, and we can multiply it by both sides inside. So if you do minus 8 times 2.5, you'll be left with negative 20. And minus 8 times minus 1.25 will leave you with plus 10x is equal to 8. Now, we talked previously about gathering like terms. 6x and 10x can be combined together into 16x, and minus 20 is equal to 8. And this leaves us with a system that we can solve very quickly. We can add 20 to both sides, giving us 16x is equal to 28. And we can solve for x here by dividing both sides by 16, which will give us 1.75. And we've solved for x. Now, we can also use this to get y. If we know what x is, we can use any of our equations to figure out what y is. So we're going to use the top one here. For the top one here, we had 5x plus 4y is equal to 10. So 5x, where x is 1.75, plus 4y is equal to 10. 5 times 1.75 is just going to be a number. It's just going to be 8.75 plus 4y is equal to 10. And you can solve this for y. What you're going to do is simply subtract 8.75 from each side and then divide by 4. You will get y is equal to 0.3125. And thus you have solved the system of equations using substitution.